Hello, everyone.
Okay.
Hello, everyone. Welcome to ASCAAD 2021 at the American University in Cairo. The 3 past day was fantastic, and I'm really happy to introduce today our keynote speaker, Patrik Schumacher. As an introductory, Patrik was he joined Zaha Hadid Architects in 1988, and 30 years ago he got his diploma in architecture, and 20 years ago he got a PhD, which has now over 30 years of experience, and he's accumulating all this experience in this presentation, which is still short for his experience. Schumacher will talk about tectonism. It's as a continuity to the theme that we have seen today. Part of them are about tectonics, and I'm sure this will be of interest to the ASCAAD community and architecture-aided design community worldwide. So I would like to welcome Patrik, and the microphone is for you now.
All right, thank you. Thank you for having me. I'm happy to join this event. So I will talk about, my intention is to talk about maybe the 40-45 minutes. Maybe there's a chance for a bit of interaction, and we have to be, I think, wrap it all up within an hour. So let me start very quickly. I wanted to show that scheme, I'm not sure if you're aware of this, in Cairo, that this is our scheme we did for New Cairo, for develop an interesting mixed-use complex with a lot of office spaces, hotel and retail, as a big complex connected up with a residential project which is behind. And as you can see here, it's a series of slab buildings clustering up with atria, and I'm also showing it because we wanted to pioneer a very new construction technique. We ended up at the very end of the presentation, we'll show the Miami Tower, where we have prefabricated concrete elements using as foam work, wrapping around the reinforcement and then pouring concrete to create a monolithic structure, but based on with a fine finish of prefabricated. Anyway, just to flick through some of these images of the scheme, where we're still hoping that eventually this can come through. We were recontacted by the developers a number of times. It's kind of a sunken valley, so because of height restrictions, the exterior appearance is slightly lower. Then you see several steps down into that valley condition. So that's just as a reminder of that we've been doing things in and for Cairo. Of course, we also have done designs for the Cairo Expo and for a beautiful tower on the Nile. But I just wanted to show you at least one of those. So this is the idea of tectonism, and some images of it. So it's a movement within parametricism, the way I describe it, which is using a lot of intelligence coming out of engineering and fabrication and contemporary methods and modes of building, which allow for the development of that new, much more richer morphology, where the form is adapted to structural forces, but also, as you will show later, with environmental conditions and parameters as drivers, but also fabrication as drivers, like you see here, the kind of showing of the 3D printing tool paths, and the ability of creating a form through hot wire cutting, for instance. These give particular geometries and particular textures. So tectonism implies a stylistic heightening of engineering and fabrication-based form finding and optimization processes. Stylistic heightening is an important element, because in the end, we architects are interested in the expressive and communicative capacity of architecture. And for me, this feeds also into into what I call the Semilogical Project. I will come to that, because it's very rich. I call it a palette of characterizing and generating a rich multiplicity of identities and characters and signatures for the various spaces and buildings, but they're also unified through that overarching methodology and organic, let's say, appearance. So tectonism is, I think it has been maturing strongly in the last 10 years. Parametricism is now already going for over 20 years. So this is the latest and most sophisticated style within, or subsidiary style within parametrism. So parametrism for me is the big epochal style, which fits the computational age and what I call post-Fordism, production systems and working patterns which fit the computational empowered age. So that's parametrism. That's been going on for 25 years. But then within that, there's these subsidiary styles, like brutalism was a subsidiary style within modernism or high-tech. So I will distinguish a number of stages and developmental steps and subsidiary styles within parametricism. So the first one, I mean, when you started parametricism, the discovery that you could have continuously differentiated surfaces, and you develop that a single surface tectonic systems, and we developed a series of buildings and interiors, which was, fantastic innovation, that you can have one surface folding and rippling and molding itself to different conditions, and this way you generate a lot of continuity between different aspects. Then we had these kind of closed volumes, blobs, but the way they fuse and aggregate is another interesting way of making more complex compositions. And of course, they're also very highly adaptive. Most of these surfaces and volumes become highly adaptive, fit into different site conditions, and also connect up, fuse, hollow out, and basically deform to fit better into context conditions. So there's some of the examples, and I think there is this idea of swarmism as well, which you can use in urbanism or on facades. The proliferation of swarms of elements, each of them which adapt to, in a sequence of differentiation, to those around and to existing context conditions. So you apply that to facades, you apply that to maybe fields of furniture or urban fields. So these are different, let's say, subsidiary styles within parametricism. I mean, I'm not sure if, but tectonism is quite different. So that adds something unique and new and different, that is richer, because we're now expressing structure stronger, we're expressing more consciously modes of fabrication, rather than having a design and hiding structure and maybe smoothing over the different fabrication techniques. And that makes it more expressive. And that's important if you do large, complex campuses, or if you're talking about larger institutions, which need to be more differentiated, where the older forms of parametricism, although they're quite versatile and differentiated, become maybe too monotonous. So that's why you see here, before parametricism was maybe these smooth surfaces, mostly in white or gray. And now we have these richness of geometries and textures and colors and materialities. And also the geometry isn't just NURB surfaces anymore. It's tensile, anticlastic minimal surfaces. It is maybe compression only forms, inflatable forms, catenaries, which are all different curved folding. They're all organic and fluid, but quite particular and characterful. Of course, also when it comes to larger structures, high-rise, the expression of skeletons is an important point. Now, this is picking up on the theme, which is quite deep in the history of architecture, where you use, let's say, morphologies that come out of construction. For instance, these kind of the way you dissect an arch with these wedge forms, and then it becomes artistically heightened and expressed and made visible. They become kind of ornamental and features, recognizable features, also proportions, etc. So this is an important theme, which isn't only in the 21st century. It's a really deep feature in architecture. You work with the necessities, and that becomes your palette, and then the features of that become, let's say, ornamentally heightened. But this is, in the end, ornament is also functional in terms of characterizing, giving expression, and communicating purposes and distinguishing different purposes. So anyway, the idea here is that you have performance-based design, via engineering logics and structural rationality, environmental rationality, and fabrication rationality. There could be more, and that these then become the drivers for the artistic project. But the artistic project is in the end also a communication project which empowers end users to understand where they are, the importance of a particular space, and distinguish different spaces from each other. So you know, of course there's a beautiful variety in the Gothic, where these are structurally optimized to at the time forms, but then they're of course also playfully, in inverted commas, or artistically heightened into ornamental features which give character and identity to those spaces. So that's one interesting example, and there's a beautiful project of one of my students is now working with us, Maria Cironi, at AADRL, where we took this idea, or she took the idea of the Gothic and said the beautiful articulation of the interior maybe could also be visible on the exterior, and then we add the contemporary conditions instead of a serial repetition of the same, let's say, bay over and over again, to make that variation, that sweep, where the form adjusts to a road or to a river, to a landscape condition, where an array and series of parametrically varied arches also fuse, and then you have not only compression but also tensile structures integrated. And then we're looking at different articulations also of the profiling of the element. Of course, we're going away from, let's say, arcs to more parabuloid or catenary forms. We're talking about compression elements and inverted catenaries, if you like, tensile elements. Anyway, so that's an early example within the academic kind of explorations of a tectonism. And you can see the elegance, beauty, the level of articulation you get. And it's an advanced stage of parametrism. And then in the office Hadid Architects, we tried it as well in a number of projects, particularly in the Middle East, where we have also the examples of domes and maybe arrays of domes for various institutional buildings, where, you know, parliamentary complexes, etc. Of course, the great inspiration for some of these coming from somebody like Gaudi or Fiotto, and then at AADRL, we did a lot of material experiments. So we don't go straight only into digital tools, but we're working with models, physical computation, if you like, form finding in the spirit of Fiotto, and there are endless of these experiments with knitted textures, with maybe stretch material, where we mold material, crack up material, have elastic material like fabrics, etc., and then structuring that differentially. So these are non-homogeneous materialities, because these stitching arrays make the material non-homogeneous, and then you then stretch it or fill it with plaster. You get quite interesting results. You know, sand casts, but also simply sand flowing and forming these conic forms. Anyway, this is an interesting exploration. We then try to find tools, algorithms, or create them to replicate that. So expanding the repertoire of digital exploration inspired by material experimentation. So actually, Parametrism 2.0 had a lot of the, let's say, contemporaneous protagonists, and they were all operating somewhat in the domain of tectonism already. So it's a natural evolution, and it deserves to be marked as a subsidiary style, because it's really a new stage, and with new level of ambition, sophistication, also difficulty. It's not easy to do, because you need to understand structure, you need to understand fabrication, you need to understand environmental conditions, and you need to bring in a whole lot of simulation tools again to get a handle over these forces. I mean, there is a lot of help with a lot of these plugins coming into Grasshopper. But it is definitely a challenge. And again, there's fantastic examples. We've looked at Gaudi, at Dieste, and Fiotto in particular, as being the great example, not only for parametrism as the prime precedent, but he's also a precedent for tectonism. And the interesting thing, the importance of Fiotto is that he did these form-finding geometries, whether they're tensile forms or other forms like shell forms, over open and free-form ground plans, other than compared to traditional walls, which are always maybe over a circle, over a square, or even somebody like Candelo is fantastic. He's done simple symmetric forms, and Frei Otto has these kind of open plans. And again, I also want to mention, in that spirit, Philip Block, we've been working with, has this ability to create what he learned from the traditional architecture in terms of compression-only walls, to give that over the free and adaptive footprint you might want to develop in a contemporary architecture in a complex site with multiple institutional components, which you shouldn't and wouldn't fit into a symmetrical figure. Fantastic work, and at the heart of tectonism. You can see the thinness of the shell, so it is really truly optimized, but then also showing the tessellation at the top end by leaving not smoothing out the surface and showing the different tiles which come together. And the beauty here is that there's no cement, it's pure pressure which holds these things together, as you can see in models like that. So this is a movement, which we're proud to be part of and working with our own research teams, and some of our buildings I will show at the end as well. So this is some of our collaborations with Philip Block we did. But again, it's in the spirit of what AADLA has been doing for many years in terms of, for instance, tower structures and reticulations or ribbing patterns on slabs. And of course, using tools like the principal stress line tools, or later I'll show you topology optimization, and you apply that also to shells. So you do the shell form, the global form itself is an engineering optimized form, a hyper, and then you can apply the stress line to make that a grid shell or ribbed shell. And that's what we did with the kind of reinterpretation of one of the Candela shell churches. We asymmetricized it, then we turned it into a grid shell with tubes, and we run the pattern wasn't a generic grid pattern, but something which followed the principal stress lines. And then we layered it in three layers. And I think we got a kind of beautiful result. Once you throw light on it, it nearly becomes automatically ornamental by itself. Because there's a beauty and logic in these rational and optimized forms, tensile forms. Again, over and over again. I mean, this is for me belonging to tectonism, because you don't draw these forms, you don't invent them. You have a tool that finds the equilibrium form at the minimal tension, and then you run the seam lines also in an optimized way to minimize distortion or stress in each partial segment. So these are the examples. 3D printing, of course, is beautiful in itself. Wouldn't give me much constraint. It has allows for new fineness, and this is basically allows for very, very intricate realization of something which has multiple steps of form finding. The global shell form, then the ribbing, so taking away material where there's less stress through making it not differently thick, and through perforation. So two types of erosion, and in the end generating something highly intricate, which is nearly as intricate as an organic creature, if you like. And then we started various printing experiments in half scale and full scale. And there's a whole, and then using these techniques of form finding and structural ribbing, but then the translation being not through 3D printing, but through another layer of geometric optimization, which is to do with having, straight profiles and for instance conic. That means sheet materials which have to be used as an additional constraining, which gives additional discipline to a form like that's different from 3D printing. And this is all the methodology and paradigm of tectonism. The global form, the ribbed geometry, but then the detail form very much strongly guided by the constraints of materiality and fabrication. We were, working with timber and 3D printing in various ways with the robotic arm and nozzles and so on. There's a whole show we had at our gallery with works our own works mixed in with the works of, for instance, the Bartlett and the AA. So that's a new aesthetic, a new exploration, particularly if you're talking about robotic fabrication and printing methodologies or discrete assembly through robotics. You get a very different aesthetic. Of course, it's still organic, it's still parametricism, I would argue, but it is a new subsidiary style with new powers and a new beauty and efficiency. So some of our ex-students who've generated, I get enthusiastic about it, and there's a number of startup companies actually from around AADRL, Bartlett, Zaha Hadid Architects, investing in these technologies. Another thing interesting, hot wire cutting is about 25 times faster as milling when you want to make molds. It gives a certain character and constraint. You're not as free, but that's good. That gives a constraint and therefore a particular specificity to all those pieces made by that, which makes them into a family which you can distinguish from others. Now, another big topic is structural optimizations through topology optimization. I mean, there you don't. You actually find the forms. You just place load points, support points. The load points are the interim floors where you want to suspend activity in space, and then you run the algorithms, and you can see how intricate and beautiful these structures are compared to what you might be able to draw up, by simple a prioris like we do. And so there's a whole exploration there. AADRL particularly, we also started to use it at the office, and the results are quite interesting. I have a new iteration of this which I haven't prepared yet for lectures, but out of that comes, and I will show later, we have some of those skeleton buildings which we have realized, like Miami and like Macau. So, but also the whole world of shells, the global form, the ribbing, and perforations where they could come in, and that's where. And then of course there's choices. You have the tool gives you the lines, the primary lines, for instance, if it's not and then there is choices of extruding them out, of eroding them, of giving particular profiles when you make your fabrication choices and the articulation choices, whether it's concrete or steel or timber or cast. These are very different expressions of an underlying global form and reticulation pattern, and these are and then also choices you make to characterize different spaces, even if they follow an overall, that's the optimization principle. They're quite different through their material realization, and so you can make still difference in an overall complex, and that's the Algiers government palace and presidential residence, where we have so many shells and different types of spaces where we wanted to differentiate through the different modes of articulation. Similarly, I ran this experiment at GSD a number of years ago with tectonism and shell formations for Google Campus, and you can see that it's important to have different materialities, different colors, different forms. The risk of monotony in large complexes means we need to move from parametrism to tectonism. And we have different versions of these, which we created with my different student groups. And I realized at the end, they're all beautiful, even though they're strongly differentiating each of them. They're so, at that scale, it becomes nearly monotonous. So we need maybe a combination of these three sketches and schemes in one project and integrate different modes of shell formation, for instance. There's the catenary version. And so this is an interesting example for me. If you look at the different experimental pavilions, this coming from Stuttgart, Achim Menkes and his teams. And it's interesting how similar they are on many levels and how different they are. So we have differences, contrast, and similarities, of course, always it's potentially simultaneously. So you can make an interesting family of where they belong together yet are distinguished. So that's for me that shows how tectonism is a fantastic repertoire for what I call the semilogical project. And you can see in the end, the vision is not a kind of homogeneous desert, but an ecology of species which integrate and adapt to each other, but also have strong differences. Minimal surfaces is another interesting exploration, which can be translated with tensile surface, or the idea of curved folding. And they're all quite different and characterful in their own way. And so that's a research project which is, on the one hand, draws on a lot of prior research, where the computational simulations of these material formations, each of them is a project, is a PhD, and we need to be part of a network of researchers and read papers and maybe publish papers to then generate a new architecture out of this. That's why I think it's a highly ambitious thing. Of course, we can, in the end, as designers, these things end up as maybe plugins, and we can pick them up. But behind it is really a collective effort of developing the tools. And we have, of course, our in-house developers, but we also rely on being part of a big network of research. So we're shifting from structure to environmental. So you can have, you have lots of tools in the environmental engineering. Particular easy to use and interesting is the sun exposure maps, and you get these kind of differentiated exposure records, and then you can translate this, transcode that by a script into different densities, for instance, of louvers, or different directions of louvers, extrusions, and there you have a process, a methodology of making interesting, adaptive, differentiated facades, and that would be a key component of tectonism. So when we don't do these kind of slick glass towers, or we try to avoid them, and say, you adapt the in this case, it's an integration of structure and shading, and you can see how the tower looks very differently on different sides, and on the western side, it's fully closed. And you get this is the central bank of Iraq, which is under construction, or our flagship project in Saudi, where we get a strong reaction against sun orientation, with these courtyards which are oriented away from the sun and towards, but open so that wind can flow in. And this goes for courtyards, but it also goes for, and the rest of the facade, very deep cuts, very shaded, but also the same principle of orienting goes for the tensile canopies. And that's nice, because you get the kind of similar parameters impacting on solid courtyard buildings as well as on a roof canopy, and so these become similar, and an effort is made that they follow the same kind of parametric forces and they tie in with each other. And I think it's a beautiful scheme, which is partly open courtyards, partly covered atria. And again, we did this for a series of shell vaults, and to get the ribbing and the perforation coherent with the structural logic. So that's the overview on these schemes, and I want to show you a few more work on skeletons and towers, and the way this allows us to differentiate between the bottom, middle, and top of tower, the way the forces accumulate, and the way you have a possibility to open up and be filigree at the top. Very different from traditional engineering, which tells you that you have, at each height of the building, there's a new system, but then they're thinking of the system always running from top to bottom. We think otherwise. You can see it here on the right-hand side, how the system changes from a very strong kind of exoskeleton, taking a lot of the moments, and then how it thins out, and at the topper part is maybe the core and outriggers, or just core and framing take over. There's a kind of system migration system shift, and we've done a number of those when we're trying then to integrate a facade, recognize the skeleton and represent the skeleton behind, for a building in Bilbao, or residential buildings in Brisbane, Australia, and show a little bit more the building in Macau. And what's beautiful about this exterior skeleton is that it allows the possibility of a fantastic interior void that you can navigate with panoramic elevators. This is the little handheld, my phone, making a kind of movie of that. And well, so there is advantages to optimizing on structure and allowing voids to appear, which are fantastic for internal navigation, having deep vistas up and down the tower, having panoramic elevators roaming through, and having these fantastic social spaces suspended in these bridges and voids, whether it's the gallery space, a restaurant like this, or the breakfast room like here. Here you see the elevator pushing past all of these scenarios, and some kind of amazing things. And wherever you are, you know that you're in this building, that the structure follows you around, even within the room or on the roof, terrace and pool. Again, I mean, when you really, of course, when you work with super large span, you can't avoid the structure, but then also to show some of that remains important to us, and not to hide it behind cladding. So we have these fantastic large span structures, these big kind of petals, which are launched from these major mega columns, but these columns are also, like in our secular, light wells. But in the center, we have exposed the ribbing pattern for the big orientation space. And wherever we have columns, I mean, they are really like funnels, which at the same time bring light at the exterior, in the interior. And then we have big lighting articulation guiding you out to the gates. And then this light opens up into an actual exterior courtyard. We have gardens at the end of the gates as well. Anyway, so I wanted to show that, as well as finally the Miami Tower, which is has the techniques we originally developed for the stone towers in Cairo. We finally used here, so we have we'll review detail later. But what is interesting is we have a kind of skeleton which is very strong at the bottom, but with an open corner, because the entrance is over the corner. And then we developed the scheme where we allow this to differentiate to be with 3 bays, 2 bays, and then only 1 bay at the top. So we have also 3, 2, and 1 apartment, and at the top it becomes very filigree with the corner splitting once more. So you can see there's a rhythm to the tower, and it allows for different product and different social space to distribute, rather than have a monotonous, generic grid like all the other towers. I think there's a lot of advantages in legibility, in differentiation, in beauty, in structural efficiency. And that's what Tectonism delivers. You see this fantastic kind of cantilevering balconies also later on. It's quite beautiful. Here is the bottom we had in situ, which later was clad. And then here we have starting the system, where we're bringing in the prefabricated fiber concrete elements and tie them together around the rebar, and then filling it up, and we end with a monolithic structure. And also these balconies, all of these are prefab, because this is for speed of construction, and also for not every region has the ability to do fine in situ concrete. But we wanted concrete rather than this kind of Miami white render, which also gets dirty all the time. You have to repaint it all the time. And we thought something slightly more solid would be beautiful, and it's still light colored, so it fits into Miami feeling, but it is very beautiful, and sometimes super large elements with very fine joint lines, super precise, which generate these structures. And you can experience them on the pool deck, and then also the balconies with a strong cantilever, and the huge span, balcony cantilever at the top. Penthouses where the penthouse has a full width of the expanse of the tower footprint, and then at the corner you have also this kind of split columns. At the top of tower, we have this fantastic double height social space again with some amenities and a helipad, which is fantastic to stand up there, by the way. So that's the project I wanted to show. Tectonism, I think that's it. I recently had a Facebook post you can look up saying kind of forget everything else. It's the only game in town. All other styles and paradigms are, let's say, yesteryears, retro. And if you want to be, and we need everybody to focus on this because it's very difficult. It's sophisticated. It takes all the best knowledges and techniques and powers of engineering, of architecture to make a more refined and adaptive and light-footed product. And I think we everything else, as I said, is really crude, and the excuse would be that it's too difficult to participate, that you haven't learned, that you don't have the knowledge, you don't have the time. Money, of course, these buildings are still a little more expensive, but these will be more economical than anything left, right, and center of it, because we can, in the end, substitute material effort with intelligence and computational effort, which becomes ever more economical in terms of environmental, in terms of embodied engineer and material kind of usage. Tectonism is also the most light-footed. So that's my pitch, and let's I don't know, I maybe stop sharing and we can have a debate.
Okay, thank you very much, Patrik. That was really an exciting presentation, a very thorough presentation covering many countries in terms of implementation of your project, as well as covering various aspects, starting from the main topic, covering also structure, engineering, optimization of structure and components, even reaching a lot in terms of environment and how your buildings and your design fit in different environments in the world, which is fantastic. And I'm sure the audience there have a question for us. You can also see the screen yourself, the question, but I can't.
Yeah, no, I cannot see anything. I only see you.
Okay, you can see only me.
At the moment, yeah.
This is a quote from Facebook. The concept of style deserve to be defended.
Yeah.
Concept. Okay, that's. So while we are waiting for questions, I'll start mine. Yeah. I mean, the last time I attended your lecture was in my university in Aberdeen. This was just before the lockdown.
Okay.
And, certainly remember that. And the content was totally different. So there is quite an extensive amount of knowledge that you share today that is evolving every year. If I select some of my notes, let's talk to the practicality first. In terms of when you talk about tectonics, there is an inspiration that you mentioned from culture. I'm wondering if you use you mimicate the culture, or how you make a representation of the culture in different way. How this wire between the original culture and its vision in nowadays is evolving.
Well, I mean, yes. So I also talk in this respect in terms of what I call parametric regionalism, and you can call it tectonic regionalism. And I mean, Frampton was talking about already about critical regionalism, because modernism, although it was quite generic in many ways across the globe and hadn't that many tools of local adaptation, it tried too. I mean, if you look at some of the brise soleil, which became more strong in Africa and in India, so there was also the idea of local adaptation to some extent. So the way it works, I think climatic conditions had an impact on morphologies, and we look closely at this, but also local materials. So which also is helpful for overall footprint to source locally if possible. And there's also and learning from the vernaculars in this way, but trying to understand the rationality and translate the evolved, let's say, traditionally through traditions evolved solutions which also withstand the scrutiny of science. So there's an optimization process. Historically, it takes maybe hundreds of years, but there's something to be learned. If it can be scaled up, if it can be translated into contemporary conditions, and some similarity, some sense of local embeddedness emerges out of that. And it could also be intuitively fostered. So when we go into a region, when we go into a site, we make that effort of cultural embeddedness, and we use, as I said, local, trying to learn from the local morphologies, because they were passive systems a lot of times. They had also the concern of withstanding the time. So it's durability, it's climatic comfort without a lot of active energy input. These are the things we learned. And the use of certain materials. So that's the way that parametrism and tectonism in particular can have this task of local embedding and quite beautifully and quite nicely. And so in our work, you can see that there's a difference in what we're doing often in Middle East from what we might be doing in Europe, or North America, or China for that matter. So, or the tropical regions. Tropical regions are quite different as well. Again, much more open with large cantilever roof and so on. So we do that, and a lot of people do it intuitively, but we do it systematically.
Mm-hmm. That's very interesting. Just on the top of this question. When you inspire from a local architecture, do you see the culture or the climate influence from that? Because it can be. Of course,
we need both. We need to. I mean, the culture is of course the bit which is more malleable, which changes fast. So to the extent that that culture is still different, it comes also through the brief, of course. What kind of spaces are requested, what the expectations are. When it comes to a project like MOS, the culture is very stable, and that imprints itself strongly. But in others, when you're talking about bringing multinational companies to Cairo, then the culture is more of a global culture.
Okay, great. Thank you for that. A question from the audience. I have Ahmed and Hassab, and I think he's from Egypt, because his question is related to if you have to design a building beside the pyramids, what will be your approach?
Well, I mean, we had what was beautiful. We had the launch of the Stone Tower project right next to the pyramid. So they built some kind of beautiful platform, and with and we had a party there. I don't know, quite frankly. I mean, it depends what kind of structure it is. I would probably not build modern and small or pyramids next to the existing pyramids. I would respect them as something which we always need to see in contrast to how we frame it and what we put next to it. It really depends what it is. But what might be nice to use work also with maybe with stone or sand. And I mean, I'm just thinking on the spot, there's this beautiful research in using glass lenses to 3D print with sunlight and with sand, by melting or the sand into harden it into a 3D print. So maybe if that would scale up, that would be an interesting technique, because then you would morphologically you would be very different, but materially you would, and color-wise, you would be totally within the range of the pyramids.
Okay, I think that's a great approach. You are not disturbing the existing pyramid, and so that's a clever and a great integration to site without disturbing the history that is there. The other question is someone looking, I think, for a lesson of architecture, a whole teaching program apparently from this question, which is from this was from Italo Guedes, and he's asking what's your approach, the whole process apparently, but you can summarize that from the conceptual design to the going from the first idea gradually to the construction, even to the smallest component. It's a long question,
that has changed over the years, because when we at the beginning, when we, for instance, still within the infancy of our developing our language, of our understanding of architecture, maybe even we were in deconstructivism still, and the early stages of pragmatism, we didn't have, we were quite open-ended. We were just doodling and playing with form and allowed, this kind of auto-inspiration through the sketch and lead us somewhere. We didn't have much of a preconceived sense. And now I think to some extent there's still that element to it, but much more, we know more the range of options we have on references within our work, but also we're pre-constraining. Tectonism relies on the fact that the tools in which we're searching the solution are pre-constrained by the logic, so we don't end up, we already exclude a lot of irrational forms, which are structurally irrational or environmentally irrational, depending, because we're pre-constraining the search space and the site, and we're using these tools to have something more adaptive. That's tectonism. So, but it relies on the fact that we have done that many iterations already, and we know which tools are relevant and that we can use them. So we become more. It's very innovative still, and but it is less totally open-ended. So that is and that might further tighten up. We also have to some extent, really, if you're a student, I don't know if the question comes from the students, you have a year to develop a project. In a professional context, you maybe have 4 weeks, and that means the concept has to be there quick. That's why it's important that we also parallel up with research teams. We have longer time, or working with students, working academically. But in terms of professional process, it's quite compressed. And a lot of things are pre-constrained, but that makes also for it really implies a very mature design team, methodology, paradigm within which we can search. But of course, the power of the tools means that we can still search, find unexpected solutions sometimes, but they fit the paradigm. Yeah,
That's a very clever answer. I think it's right. The process is from academia might be lengthy, but professionalism is.
And that's why we need to we need to go through this lengthy processes, and then we have to find a solution, and then we can then we look at the end and the beginning, and we can then in the next stage we can shortcut that. Because it took a year because you went in all sorts of wrong directions, and all these branches, dead end branches, you don't have to repeat when you do the similar project next time.
Yeah, I think that's capitalizing on the past is an answer to another question that was there. So it's capitalizing, but with the reference to the two previous projects, and with a different approach for future design. I have a quite clever question here regarding. This is from Zaki Malasi. he was questioning the interaction between architect and the client. You know, in this complex design that you have, which can be sometimes challenging for even some architect to imagine them and to understand them and to see how they work. He would like to know, and would like to know as well, what is your process of and the feedback and the discussion with the clients, and then the back and forth dialogue until the project is finalized or it is construction. And I would say, adding to that, what will be the feedback or the post-occupancy evaluation of the project? Do you follow up on that, or?
Yeah, I mean,
it's a lengthy question, but it's very
okay,
important.
very good. So first of all, on competitions, there isn't much interaction, although recently there's been competitions in stages where the client wants to see interim results. So we get some feedback. Otherwise, you have to really interpret the requirements and needs of the client. But where we are much stronger than we've ever been before, of course, is in presenting the final result. It's really user experience focused. So we have final renderings and walkthroughs, and we animate and focus for the client really on the result, the interaction spaces, the final purposes of the institution and how they're realized, what's the look and feel and functionality, social functionality. And that's what we focus on. We're very good at that. And we also know that if we render something, we could actually build it. And you can demonstrate that, we can demonstrate it how we're showing previous competition, let's say, renders and final results. We know what we're doing and can do. When it comes to direct commissions or after the competition, there has been a lot of rethinking. Of course, the way we interact with clients, we do many options. We allow them to participate by selecting versions, options, concepts. We integrate them in the decision-making process. And again, we have to then always visualize in ways that are legible. And what we've done recently more and more is we're doing VR models. So we're allowing a three-dimensional immersive experience where you can go in and look at everything and explore. And a lot of clients find that very helpful. Now, when it comes to post-occupancy, what we do actually in terms of, we do a lot of pre-occupancy simulation, so what I call live process modeling. We have a specialist team we're developing agent models, so we can really understand how users move through the space, where they would meet, could meet, the number of encounters and communications which you generate with different options, and then select maybe the one where you generate more communication. But also post-occupancy, it's not systematic. I mean, the problem is, or the question is, who is financing this? I mean, we have a track record, and we have, in particular with repeat clients, and we also go back to our buildings, particular public buildings, but it's anecdotal. There isn't a so that's an admission of, let's say, a gap which I think the discipline is facing in general. And a firm like Zaha Hadid Architects probably should have a systematic post-occupancy analysis team, but then again, I mean, it's a resource-constrained world where we're competing, and it's more informal. You get good feedback, you get letters from clients, but it's true. And we do empirical research now with our research team in terms of, if we have a corporate client and we're researching and testing their current occupancy with questionnaires and with records, and then try to simulate and optimize, we would have to go back to verify our results. That's what we understand, and we at the moment not in that stage. We're doing predictions, but predictions for buildings which haven't been built yet. In this case, we would definitely feel the duty and necessity to go back, because we made some kind of simulative predictive at least appraisal and estimation between different options and versions, and that should be followed up with some degree of measurement. But I think it's a general issue in the discipline that this is largely lacking.
Yeah, I totally agree. I mean, post-occupancy evaluation is something that needs to be introduced by RIBA or every country to in the
the end will come from clients. If clients would be more sophisticated and demanding, they would say, "Sure, give me a track record and with respect of post-occupancy analysis and verification." That's what the clients. If they start demanding that, then architects will start doing it.
Yeah, exactly, and that this should be accountable about any failure in the project. And failure is not just in building that demolished; it's also about delivering it, about the behavior of the building in terms of.
In particular, of course, engineers also need to do that, because there's a lot of times you have all these certifications, and I've heard that in terms of some of the lead, the prediction and the certificate relative to the real there's a substantial gap, and I've heard that in the German system that gap is much smaller in terms. So this is a concern. I mean, here we're talking about measurable results. What I'm working on is making the social functionality measurable too.
Which, yeah, it is part of the POE as well. Maybe the last question, because we have only 3 minutes left in the session. In terms of practicality, the design that you are doing are really, I would say, qualify them as futuristic for some of them, and passing from the design to the construction, it's sometimes this transition might be quite challenging if you don't have the right contractor who can do it, because you might have an idea that was not done before, which is the case, and how you found the right contractor and how you translate this to it's quite complex process. If the building is new, the material are innovative, the construction might be challenging, the labor might not be experiencing.
I think you're right. I mean, so we obviously are highly aware of that problem. In the early years, there were some problems, maybe mistakes we made, and clients also need to be alert to the fact. So the tender process, we got involved. We make sure that it's not only the cheapest price, or that if somebody's bidding an unrealistic price, it needs to be probed. It needs to maybe prior, of course, there are thresholds of joining a bid. And we going around actually in the tender process and go around and visit contractors and subcontractors in particular for the facade, visit their facilities, to talk to the engineers, and we mostly recommend our clients to have multiple of these compete with mock-ups, with real examples, mock-ups you can then later also point back to and saying that's what you've promised to deliver. And sometimes we also have that they're doing mock-up, which is very great, and then in the real they cut corners. So that's the one way of quality control. The other one is, of course, that we have trusted suppliers we go back to, subcontractors, and bring to the various projects, and allow them to so we know that we have trusted partners.
Thank you, Patrik. Maybe I'm greedy, but I would like a final question. How was your professional life experience with Zaha Hadid during all this time that you shared with her?
It was fantastic. I mean, it was amazing. I mean, I know nothing else, so I don't know much comparison, because I was a student when I joined her, and she was of course an incredibly charismatic figure, very, very creative, and very nice person to know and to work with. Tough and intense, of course, in many ways, but also at the time always generous and forgiving as well if you make mistakes. So it was wonderful, and in particular the energy and the let's say will to excellence was inspiring us all to do more, and always to try to do something new with every project. And even while we're maturing, there is always an element of innovation. So it was really wonderful, and it's a great loss to not have her. And just also the vision to realize these projects and the enthusiasm for every type of project. So it wasn't that she was only interested in museums and opera houses. She wanted to do everything: houses, you know, even social housing, infrastructure. And there's this kind of ambition of a universal built environment where everything can be transformed by beautiful and intelligent design approach, very similar to modernism actually, where that's first occurred, that you have everything is potentially architecture, and also all the way to the interior, to the design, to products, to fashion, where we designed some nice outfits and suits and items too. So it's like the Bauhaus. You have there was this kind of idea of a universal scope. Wonderful. I mean, of course, and she was the founder of something wonderful, which we still live and breathe and continue.
Yeah. That's fantastic, Dr. Patrik Schumacher. Thank you very much for giving us this opportunity to share some time with you and share your experience. And I'm sure the ASCAAD community thank you. And so I thank you on behalf of everyone. I don't have the possibility to turn on the microphone to give you a big applause, but this is mine.
Thank you. All right, I enjoyed it. So
thank
pleasure,
you,
and I hope everybody had a good time. Bye now.
Thank you. Thank you. Take care.